Very good afternoon. Good afternoon, students. Can you hear me? Whether this screen is visible? Okay. So, welcome to mathematics class. We shall discuss some more problems on limits. So, in the last class, I had completed the level 1. Today, we shall discuss level 2 problems on limits. Okay. So, yesterday, I had sent you that soft copy of this material. The hard copy is also getting ready. Within another 4 to 5 days, it will be ready. Okay. So, till then, just go through that soft copy of me. Okay. So, let's start our discussion today. Let's have a look at the first question, which is limit extends to 1. Summation k from 1 to 200 x power k minus 200 divided by x minus 1 is equal to. Okay. So, I can rewrite the given problem as limit extends to 1. Summation k from 1 to 200 x power k. You go on putting value for k starting from 1 till 200. So that will give you x to the power 1, which is x, plus x square, plus x cube, plus x power 4, etc. till x to the power 200 minus 200 divided by x minus 1. Okay. So go on putting values for x starting from value for k starting from 1 to 200. So x power k, look here, summation k from 1 to 200. Its meaning is put k equal to 1, then k equal to 2, 3, 4, etc. So you get x plus x square plus x cube plus x power 4 and so on till x to the power 200. Okay. Minus 200. This is what we have now. Now if I directly apply the limit, I'm going to get 1 plus 1 plus 1 plus 1. Each of these terms, because 1, 1 square, 1 cube, 1 power 4, 1 power 5, 1 power 10, etc. All these will give you 1, 1, 1, 1, 1, 1, 200 times. That if you add, it will be, that sum will be 200. 200 minus 200, that is 0. Denominator 1 minus 1, that is also 0. So we get 0 by 0 form. 0 by 0. As soon as we see 0 by 0, immediately we think of L Hospital Rule. So when we use L Hospital Rule, what do? We will differentiate, right? So differentiate this. Derivative of x, that is 1, plus the derivative of x square, which is 2x, plus the derivative of x cube, which is 3x square, 4x cube, and so on, up to 200 into x to the power 199, minus the derivative of 200, which is 0, divided by the derivative of x minus 1, which is 1. Okay. So now you apply the limit. Apply the limit as x tends to 1. When you apply the limit as x tends to 1, what are we going to get? 1 plus 2 plus 3, etc. till 200. 1 plus 2 plus 3 plus 4, etc. till 200. This sum, 1, 2, 3 up to 200. This sum is equal to what? N into, look at this. It is of the form 1 plus 2 plus 3 up to 200. Up to n, that is equal to, the formula n into n plus 1 by 2. So this will give you n into n plus 1. N into n minus 1. Okay. So n into n minus, n into n plus 1 by 2, which is equal to n, which is 200, into n plus 1, 201, by 2. 200 by 2, this will give you 100. 100 into 201, that will give you 20,100. That's the answer. Okay. X minus 1 will not be 0. I'm differentiating. I'm using L Hospital Rule. Pradeep, not Pradeep. Okay. So who asked that question? Kushi. Okay. So I'm using L Hospital Rule. So differentiating x minus 1, that will give you 1. Okay. So the answer is 20,100, which is the fourth option. Okay. Then let's have a look at question number 2. If f of x is equal to sine 3x by e power 2x minus 1, if x not equal to 0, k minus 2 if x is equal to 0, is continuous at x equal to 0, then k is equal to. This function is continuous at x equal to 0. So already it is given that it is continuous at x equal to 0. Since it is continuous at x equal to 0, we can write limit x tends to 0, f of x is equal to f of 0. So limit x tends to 0, f of x. F of x is sine 3x divided by e power 2x minus 1. That is equal to f of 0. What is f of 0? K minus 2. Okay. So now apply the limit. If I directly apply the limit, numerator is sine 0, which is 0. Denominator e power 0, that is 1 minus 1. 0, 1 minus 1, 0 by 0. This is an indeterminate form. So I will use L Hospital's rule. Sine 3x, its derivative will be cos 3x into 3 divided by derivative of e power 2x minus 1. That is e power 2x into 2. Minus 1 is there, whose derivative is 0, is equal to k minus 2. Apply the limit now as x tends to 0. When I apply the limit as x tends to 0, here cos 0, which is 1 into 3. So this is 3 by 2. Here e power 0 is 1 into 2 will give you 2, is equal to k minus 2. Therefore, k is equal to 2 plus 3 by 2. That will give you 4 plus 3, which is 7 by 2. K is equal to 7 by 2, which is the first option. That's the answer. Next question. Question number 3. Limit x tends to 1 by 2. 8x minus 3 divided by 2x minus 1 minus 4x square plus 1 divided by 4x square minus 1 is equal to. Okay. So here, if we directly apply the limit, numerator will be 8 into 1 by 2. I am putting x as 1 by 2. That will give you 8 into 1 by 2, which is 4 minus 3 divided by, here 2 gets cancelled, 1 minus 1, 0, minus. Here what happens, putting x as 1 by 2 means 1 by 2 whole square, which is 1 by 4. 4 into 1 by 4 is 1. 1 plus 1 is 2. Divide by, put x as 1 by 2 here. 1 by 4 into 1 by 4, that will be 1. 1 minus 1, 0. So this is 1 by 0. This tends to infinity. This also tends to infinity. So it is of the form infinity minus infinity. This is also an indeterminate form. Don't think infinity minus infinity, these two gets cancelled and we get 0. No, it's not correct. So infinity minus infinity is an indeterminate form. Okay. And now you cannot use L Hospital Rule. Many students, what they do is, okay, as soon as they say, okay, they will differentiate this and differentiate numerator as well as differentiate the denominator. That will not work in this problem. We can use L Hospital Rule only if it is of the form 0 by 0 or infinity by infinity. Keep this in mind. Even though it is true that for most of the problems we have used L Hospital Rule, but to use L Hospital Rule, it should be in the form 0 by 0 or infinity by infinity, not otherwise. Okay, now it is of the form infinity minus infinity. So what to do? Let us try to simplify this. Here 4x square minus 1 is there. If you factorize this, you are going to get 2x plus 1 into 2x minus 1. 2x plus 1 into x minus 1, right? So I will take LCM here. LCM, that 4x square minus 1 itself will be the LCM, right? This 4x square minus 1 will be the LCM. Here you are going to get 8x minus 3 into 2x plus 1 minus here as it is this 4x square plus 1 will remain. Okay, that's equal to limit extends to 1. Let me simplify this. We get 16x square. Okay, 16x square plus 8x minus 6x minus 3 minus 4x square minus 1 divided by 4x square minus 1. Okay, so that's equal to limit extends to 1. 16x square minus 4x square, that will give you 12x square plus 2x minus 4 divided by 4x square minus 1. Okay, so now if I directly apply the limit here, at this stage, if we apply the limit, we are going to get, see, when I put x as 1, sorry, not 1, right? The limit is extends to 1 by 2. I'm sorry. So it should be extends to 1 by 2. Okay. It is by mistake. If I put x as 1 by 2, just observe what we are going to get today. When I put x as 1 by 2, 12 into 1 by 4, putting x as 1 by 2 will give you 1 by 4. Plus 2 into 1 by 2, that is 1, minus 4. Okay. So 4 ones are divided by. In the denominator, 4 into 1 by 4, 1 minus 1, we are going to get 0. Right? Here 4 ones are 4 threes are 3 plus 1, 4. 4 minus 4, 0. 0 divided by 0. 0 by 0. 0 by 0 is an indeterminate form. And now we can use L Hospital Rule. Okay. So it is of the form 0 by 0. So I will use L Hospital Rule. Okay. So limit extends to 1 by 2. Differentiate this. We get 24x plus 2 divided by 8x. Okay. Divided by 4x square is 8x. That's equal to. Now you apply the limit. See what we are going to get. 24 into 1 by 2, that is 12 plus 2 divided by 8 into 1 by 2, which is 4. So we get 14 by 4. That's equal to 7 by 2. So 7 by 2 is the correct answer, which is the first option. Okay. Then let's have a look at question number 5. The quadratic equation whose roots L and M, where L is equal to limit theta tends to 0, 3 sine theta minus 4 sine cube theta by theta. M is equal to limit theta tends to 0, 2 tan theta divided by theta into 1 minus tan square theta. Okay. So here in this question, we are asked to find a quadratic equation whose roots are L and M. Okay. So we are asked to find a quadratic equation whose roots are L and M. Now, suppose if I ask you, if I give you L and M are two numbers, and ask you to find the equation of quadratic equation whose roots are L and M, then you can write like this: x square minus of L plus sum of x plus Lm is equal to 0. This you know, right? If alpha and beta are the roots of a quadratic equation, then that quadratic equation can be written as x square minus of alpha plus beta into x plus alpha beta is equal to 0. This you have learned. Okay. So now let us first find out what is L and what are L and M. Okay. So L is equal to limit theta tends to 0, 3 sine theta minus 4 sine cube theta divided by theta. That's equal to limit theta tends to 0, 3 sine theta minus 4 sine cube theta, that is nothing but sine 3 theta by theta. Limit theta tends to 0, sine 3 theta by theta is equal to 3, which means L is equal to 3. Now let us find out what is M. M is equal to limit theta tends to 0. What they have given here? Limit theta tends to 0, 2 tan theta divided by theta into 1 minus tan square theta. 2 tan theta divided by theta into 1 minus tan square theta. Okay, so let's evaluate this limit first. Limit theta tends to 0, 2 tan theta by 1 minus tan square theta. 2 tan theta divided by 1 minus tan square theta will become tan 2 theta. 2 tan theta by 1 minus tan square theta is tan 2 theta. So divided by theta. Limit theta tends to 0, tan 2 theta by theta is equal to 2. Okay, multiply and divide by 2. So tan 2 theta by theta as theta tends to 0 will become 2. So now we have L is equal to 3 and M is equal to 2. We want a quadratic equation whose roots are 3 and 2. There is nothing but x square minus 5x plus 6 is equal to 0. Okay, x square minus 5x plus 6 is equal to 0, which is the first option. Okay. Then let's go to the next question now. The next question is question number 6. Limit x tends to 0, sine of step of cos x divided by 1 plus step of cos x is. Okay. So when it comes to step function, you should be a little more careful. So you need to, especially when it is an integer. In general, limit x tends to an integer, step x does not exist. Okay. But now we have x tends to 0. It's not just a step x, it is step of cos x. So whether this limit exists or does not exist directly, we cannot tell. But however, we need to have a look at the left hand limit and right hand limit separately. Why should we need left hand limit, right hand limit separately is because when you look at step x, when x approaches an integer, or let us say 0, for left hand limit and right hand limit, it will be the value of step x will be different. See, when x approaches 0 from left side, step x will be equal to -1, and when x approaches 0 from right side, step x will be equal to 0. So here, therefore, it is better that we use left hand limit and right hand limit separately in this case. Okay, so left hand limit, that's equal to limit x tends to 0 minus f of x. What is f of x? Sine of step of cos x divided by 1 plus step of cos x. So I would like to draw the graph of cos x here. Cos x. This is the graph of cos x, right? Sorry. This is 0, pi by 2, pi, 3 pi by 2, minus pi by 2. Okay. At 0. Okay, so Sunanda has a question here. So how can we understand the bracket is whether step function or just bracket itself? Okay, so see, look at the denominator there. There you don't need a bracket, right? So then what? It cannot be a bracket. Okay, in the numerator, okay, somewhat you can understand. In the denominator, if it why there is no need of writing a bracket, right? So it is not bracket; it is a step function. In most of the cases, they will give that step x it indicates the greatest integer function. Okay. However, here they have not given. But by looking at this, you can understand. Here you don't need a bracket in the denominator, so it has to be step x. Okay. So now I want to know in the neighborhood of cos x, in the neighborhood of 0, what happens to cos x? You just look at the left-hand limit first. Let us say x approaches 0 from left side. Cos 0 is equal to 1, that we know. Okay, cos 0 is 1, that everybody knows. Now I'm interested in knowing what is the value of cos x when x approaches 0 from left side. When x approaches 0 from left side, see cos x value, it is increasing, right? At cos of minus pi by 2 is 0 and cos 0 is 1. So it is increasing from 0 to 1. So when x is very close to 0, the value of cos x could be something like 0.98, 0.99, 0.9999, etc. Right? See, when x approaches 0, when x reaches 0, at x equal to 0, cos 0 is 1. But just before that, cos x, the value of cos x is very close to 0, very close to 1, but less than 1. So cos x value may be equal to 0.9, 0.95, 0.98, 0.99, 0.999. As x comes closer and closer to 0, cos x will come closer and closer to 1. Okay. But just before 0, cos x value will be around this. But at all those points, what happens to step of cos x, step of 0.98, step of 0.99, step of 0.999, etc. All these values will be 0. Okay, divided by 1 plus 0. So sin 0 is 0, 0 by 1 is equal to 0. Hence, left-hand limit is equal to 0. Okay, see, cos x is very close to 1, but less than 1. When x approaches 0 from left side, cos x is very close to 1, but less than 1, which means cos x value may be around 0.9, 0.95, 0.98, 0.999, etc. At all those points, step of cos x, that means step of 0.98, step of 0.99, etc. All those will become 0. So step of cos x is equal to 0 when x approaches 0 from left side. So then in the numerator you have sin 0, and in the denominator we have 1 plus 0. Sin 0 is 0, 1 plus 0 is 1, 0 by 1 is equal to 0. This is our left-hand limit. Now right-hand limit. Right-hand limit is equal to limit extends to 0 plus sine of step of cos x divided by 1 plus step of cos x. That's equal to 0.98, 0.99, 0.999 are tending to 1. Yes, Vineet, but I am talking about this step of 0.98, 0.99, 0.999. They don't tend to 1. All these values are equal to 0. Okay. So now look at sine of step of cos x by 1 plus step of cos x when x approaches 0 from right side. When x approaches 0 from right side, what happens to cos x? Cos 0 is 1. See, after 0, cos x is a decreasing function. Look at the graph. Before 0, from minus pi by 2 to 0, it is an increasing function. From 0 to pi by 2, not only pi by 2, even up to pi also, it is a decreasing function. At a 0, cos 0 is 1. Soon after that, the value of cos x goes on decreasing. See, cos 0 is 1, cos pi by 2 is 0. So it decreases from 1 to 0. Now you look at x is approaching 0 from right side, which means x value may be 0.1, 0.5, 0.3, 0.1, 0.01, etc. At all those points, what happens to cos x? Cos x value, observe, at 0 it is 1. Soon after 0, it starts to decrease. So cos x value will still remain these. Cos x value will take these values. Cos x will take 0.98, 0.99, 0.999, etc. Okay. So then when x approaches 0 from left side, right side, there also cos x value approaches 0.95, 0.98, 0.99, 0.999, etc. Then step of cos x will be equal to 0. Sin 0 divided by 1 plus 0, you get 0 by 1, that is equal to 0. Left hand limit is 0, right hand limit is also equal to 0. Hence, the value of this limit is equal to 0. Is that clear? See, it is not the limit extends to 0 cos x. If it is only limit extends to 0 cos x, if you have limit extends to 0 cos x, this is always equal to 1. When x approaches 0 from left side or from right side, cos x is approaching 1. Therefore, cos limit extends to 0, cos x is equal to 1. But if you think of this, limit extends to 0, step of cos x, this will be equal to 0. Okay, let me explain again. For left hand limit, x is approaching 0 from left side. X is very close to 0 but less than 0. When x is very close to 0 but less than 0, cos x value is very close to 1 but less than 1. At 0, cos x become 1. Just before 0, cos x will be slightly less than 1. Cos x is slightly less than 1 means step of cos x will be equal to 0. Okay, so we get sin 0 by 1 plus 0. Hence, left hand limit is equal to 0. Then if you look at the right hand limit, when x approaches 0 from right side, okay, look at the graph here. Cos x is at 0, cos x is equal to 1. After 0, it is just less than 1. Cos x is just less than 1. Okay. Therefore, step of cos x, since cos x is just less than 1, step of cos x will be equal to 0. Hence, on simplification, this will also give you 0. Left hand limit is 0, right hand limit is 0. Hence, the value of this limit is equal to 0. Okay. Then, question number 7. Limit extends to 2 plus step of 2 minus x plus step of x minus 2 is equal to. Okay. Here in bracket, they have given step x is the greatest integer function. Okay. So, that flower bracket is flower bracket only. Now we are asked to evaluate this limit. Limit extends to 2 plus. We are only asked to find the right hand limit. Step of 2 minus x plus step of x minus 2 is equal to. Okay. X is approaching 2 from right side. When x approaches 2 from right side means x may take the values 2.1, 2.05, 2.01, 2.001, 2.001, etc. Okay. So, in that case, what happens to step of 2 minus x? Let us just observe. Suppose if I take x equal to 2.1, step of 2 minus x will be 2 minus 2.1, that will give you minus 0.1. 2.05, if I take, what happens? 2 minus 2.05 minus 0.05 you get. Here you get, if I take 2.01, then it will give you minus 0.01. Here it will give you minus 0.001. Here minus 0.0001. I'm just looking at the first term. Okay. I'm just concentrating on step of 2 minus x. See, when I say x is approaching 2 from right side, x value is very close to 2 but greater than 2. If I substitute those values, these are the things we are going to get. Now, what is the value of step of minus 0.1? This is equal to minus 1. Step of minus 0.05 is also minus 1. Step of minus 0.01 is minus 1. This is minus 1. This is also minus 1. So all these values are equal to minus 1. So this I'll write as minus 1 plus. Now what happens to step of x minus 2? Let us just observe. Here x minus 2, if I substitute, x is approaching 2 from right side, then step of x minus 2. I'll take x is equal to these values. 2.1, 2.05, 2.01, 2.001, etc. Then what happens here? At x equal to 2.1, if I take x as 2.1, this is x, this is x minus 2. Step of x minus 2. Okay, so x is equal to 2.1 if I take x minus 2, 2.1 minus 2, 0.1. Then 2.05 if I take 2.05 minus 2, that will give you 0.05. Then 2.01 if I take, it will give you step of 0.01. 2.001, that will give you 0.001 in this way. What is step of 0.1? This is 0, this is 0, this is 0, this is 0. So all these are equal to 0. So right hand limit will be, not right hand limit only. Here step of x minus 2 as x approaches 2 plus will be minus 1 plus 0. That's equal to minus 1. That's the answer. Second option. Okay, Karthik has another question. Sir, outer bracket, is it fractional part of function or not? It is not. It is not the fractional part of x. They have not mentioned it. It's only step x is the one. Okay. So limit is equal to minus 1. Say they have asked us to find only the right hand limit. If you are finding left hand limit also, then the things are different. Okay. So if you are finding left hand limit also, here around 1.9, if I take 2 minus 1.9 and 0.1, you get step of 0.1 is 0. Here 1.9 minus 2, 1.9 minus 2 will give you minus 0.1, step of that is minus 1. So that will also give you minus 1. Okay. So left hand limit also minus 1, right hand limit also minus 1. So it does exist and the answer is minus 1. Okay. But however, here they have only asked us to find out the right hand limit and the answer is minus 1. Okay. Let's have a look at the next question, which is question number 9. Limit extends to 0 e power step of mod sin x divided by step of x plus 1, where step denotes the greatest integer function. Okay. So now here step is there, mod is also there. X is approaching 0, so better to go for left hand limit and right hand. Left hand limit extends to 0 minus e power step of mod sin x divided by step of x plus 1. X is approaching 0 from left side. When x approaches 0 from left side, what happens to mod x? Mod x, you know, it is defined as x if x is greater or equal to 0, minus x if x is less than 0. In the same way, mod sin x is defined as sin x if sin x is greater or equal to 0, and it is defined as minus sin x if sin x is less than 0. Okay, so sin x, it is sin x if sin x is positive, minus sin x if sin x is negative. Now I am talking about x is approaching 0 from left side. When x approaches 0 from left side means we are in the fourth quadrant. X is very close to 0 but less than 0. So if x is in the fourth quadrant, sin x is negative. Therefore, mod sin x will be equal to minus sin x. So this will become e power step of minus sin x divided by step of x plus 1. That's equal to x approaches 0 from left side, sin 0, it will be 0 only. And here we are going to get e power 0. Okay. Step of that is also 0. Then step of x plus 1. When x approaches 0 from left side, here what happens to sin x? Sin x will approach 0. So step of that is also 0. And here x approaches 0 from left side, means x is very close to 0 but less than 0. I can take x is equal to say minus 0.1. 1 minus 0.1, you get 0.9. Step of 0.9, that will be equal to 0. Okay. So this is an not indeterminate. This tends to infinity because numerator is 1, denominator is 0. Then if you look at the right hand limit, what happens? Limit extends to 0 plus e power step of mod sin x divided by step of x plus 1. X is approaching 0 from right side. That means x is in first quadrant. In the first quadrant, sign is positive. Therefore, mod sin x is equal to sin x divided by step of x plus 1. That's equal to, apply the limit of from x tends to 0 plus x is approaching 0 from right side. When x approaches 0 from right side, what happens? Sin 0. Sin 0 is 0, so e power 0. What happens in the denominator? Step of x plus 1. X is approaching 0 from right side means x is positive. So x may take value 0.1, 0.01, etc. At all those points, what happens to step of x plus 1? X is equal to 0.1 if I take 1 plus 0.1, okay, which is 1.1. Step of 1.1 is 1. E power 0 is 1, 1 is also 1. 1 by 1, we get 1. Left hand limit tends to infinity and right hand limit tends to 1. They are tending to two different values. Therefore, this limit does not exist. Okay, next. Okay, let's have a look at question number 10. Another question on step function only. Limit x tends to 2 plus step x whole cube by 3 minus step of x by 3 whole cube is limit x tends to 2 plus step x whole cube by 3 minus step of x by 3 whole cube. When I say x tends to 2 plus, that means x is approaching 2 from right side. X is slightly greater than 2. Okay, slightly greater than 2 means you can imagine 2.1. Suppose if I take x as 2.1, then step of 2.1. Step of 2.1 is 2. So this will give you 2 cube by 3 minus step of x by 3. X is equal to 2.1 if I take 2.1 by 3. What is 2.1 by 3? It is around 0.67 something. So step of 0.67, that will be equal to 0. Okay. So the answer is 8 by 3, which is the third option. Okay. Now you might be thinking, sir, why did you take x is equal to 2.1 only? See, if I take anything other than 2.1 also, this result is true. When I say x is approaching 2 plus, look at this. Imagine this as the real line. Okay, real line is straight. Okay, so here is 0, 1, 2, 3, etc. I am talking about x approaching 2 from right side means x should be in this interval, right? So x value may be around 2.2, 2.1, 2.05, 2.01, 2.001, etc. So instead of 2.1, if I take 2.01, then also result will be true. Because step of 2.01 is also 2. 2 cube is 8, 8 by 3 minus 2.01 by 3. 2 by 3 is 0.6666. So 2.01 by 3 is also very close to that, 0.66667. So step of 0.66667 is equal to 0. Okay, in that case also we get the same answer. Therefore, 8 by 3 is the answer. Next, 13th question. If summation r from 1 to n 2r minus 1 is equal to x, Then limit n tends to infinity 1 cube by x square, 2 cube by x square, 3 cube by x square, etc. up to n cube by x square is equal to. Okay, so first we shall find out what is x. Summation r from 1 to n to r minus 1. You go on putting value for r. Put r is equal to 1. 2 minus 1, that is 1. Plus, put r is equal to 2. 4 minus 1, 3. Put r is equal to 3. Then 5, 7, 9, etc. Put r is equal to n. Then 2n minus 1. That is equal to x. 1 plus 3 plus 5 plus 7 plus 9, etc. up to 2n minus 1. Sum of the first n odd natural numbers. This is equal to n square. So we got x is equal to n square. Okay. Hence, now the given problem will be, I can write like this. Limit n tends to infinity. See, in the denominator, x square is, there is a common denominator in x square. So numerator is 1 square, 2 square, 3 square, etc. till n square. Oh, sorry, cube. It is 1 cube, 2 cube, 3 cube, 4 cube, etc. till n cube divided by x square. We can write like this. Then 1 cube, 2 cube, 3 cube up to n cube. For that we have another formula. What is that formula? N square into n plus 1 whole square divided by 4. Divided by x square, that will be n power 4. X is equal to n square. So x square is equal to n power 4. N square gets cancelled. We can write it like this. Limit n tends to infinity. N plus 1 whole square, I will write that as n square plus 2n plus 1 divided by 4 into n square. That's equal to. Now it is n tends to infinity. Now both are polynomials of the same degree. Numerator is a polynomial of degree 1. Denominator also, sorry, degree 2. Numerator is a polynomial of degree 2. Denominator is also a polynomial of degree 2. Okay. So, the value of this limit is equal to the coefficient of highest power of n in the numerator divided by the coefficient of highest power of n in the denominator. So you will get the answer as 1 by 4. Okay. Next. So whatever the doubts you have, if you want me to explain any problem again, that you can ask me at the end of the session. Okay. So after the conclusion of the class, I'll clarify all of your doubts. Okay, don't worry. Now let's go to the next question, which is question number 16. If limit x tends to 0, cos 4x plus a cos 2x plus b by x power 4 is finite, then the value of a and b are respectively. Okay. So they have given that it is finite. They have given that it is finite means if we directly apply the limit, what are we going to get? So if I directly apply the limit, I'm going to get cos 0, which is 1, plus a into cos 0 is 1, a plus b divided by, when I put x as 0, I'm going to get 0 here in the denominator. So now it depends on the numerator now. If this is positive, if it is positive, then positive number, some positive number here, divided by 0, this will tend to plus infinity. Okay. And suppose if it is negative, if this numerator is negative, let us say if it is negative, denominator is 0 anyway. If the numerator is negative, then 1 plus a plus b divided by 0, this will tend to minus infinity. Okay. See, if the numerator is positive, then it will tend to plus infinity. If the numerator is negative, denominator anyway 0 only. When I apply the limit as x tends to 0, I'm going to get 1 plus a plus b divided by 0. Right. Now, if the numerator is positive, then it will tend to plus infinity. And if the numerator is negative, it will tend to minus infinity. But look at what they have given. They have given that it is finite. They have mentioned that it is finite. Okay. So it is finite means this numerator cannot be positive, cannot be negative. Because if it is positive, then it is tending to plus infinity. If it is negative, then it is tending to minus infinity. Okay. So it is tending to either plus infinity or minus infinity, depending on whether this 1 plus a plus b is positive or negative. Okay. So in both cases, we are getting infinite only, which we don't want. They have already given that it is finite. So it cannot be positive, cannot be negative, means then there is only one option left. What is that option? Can you tell me what is that option? Yes, Sumit, you're right. It can be 0, right? It cannot be positive, cannot be negative, means it has to be 0. So it has to be 0. So 1 plus a plus b is equal to 0. So a plus b is equal to minus 1. Now look at the options. In how many options do we have a plus b equal to minus 1? Look at this. Here we get 9. That's not the answer. Here we get minus 9. That's not the answer. Here we get minus 1. This could be the answer. Here we get plus 5, plus 9. That's not the answer. Therefore, third option is correct. That's all. Okay. So third option is the answer. Now today we are lucky that the options are in this way. Okay. Where there is only one option, which is where the sum of those two, a plus b, is equal to minus 1. So that has to be the answer. But on another day, we may not be that lucky that every day you will not be that lucky, so that only one option will satisfy the given condition, this condition, right? There may be more than one option also. Let us imagine a worst situation where we have the options as minus 5, 4, minus 6, 5. This is one option. This is one option. Minus 4, 3 is one option, and minus 2, 1 is another option. So in a worst scenario, we may end up having all 4 options will satisfy this, a plus b equal to. In this, you observe, for all the 4 options, a plus b is minus 1 only. Then what to do? Leave that question and go to the next one. So yeah. Then I'll explain what to do. After using L Hospital, now you know if 1 plus a plus b is 0, you can use L Hospital Rule, right? So you have cos 4x plus a cos 2x plus b, cos 4x plus a cos 2x plus b divided by what? X power 4 we have. Okay. So given that it is finite, therefore this numerator should be 0 when we apply the limit. So that means it is of the form 0 by 0. Therefore, we can think of L Hospital's rule, use L Hospital's rule. Derivative of cos 4x is minus sine 4x into 4 minus a sine 2x into 2 divided by 4x cube. Now, if I apply the limit, sine 4x is there, sine 2x is there, 0, denominator also 0. 0 by 0, again you use L Hospital's rule. That will give you minus cos 4x into 4. Already 1 4 is there, so it will become 16. Minus a into cos 2x into 2 into 2, so it will be 4. Divided by 12x square. Now, if we apply the limit as extends to 0, we are going to get minus 16 minus 4a. Okay, I'm putting x as 0, cos 0 is 1. So minus 16 here, here minus 4a divided by 0, right? So again, we are in the same situation. So what is that situation? Again, we are talking about this minus 16 by minus 4a. If this is positive, if it is positive, it will tend to plus infinity. If it is negative, suppose if this is negative, then it will tend to minus infinity. But given that this limit is finite, so this numerator must be positive, must be equal to 0. So minus 16 minus 4a equal to 0, hence 4a is equal to minus 16, a is equal to minus 4. A is equal to -4. So A is equal to -4, substitute here, you get B is equal to 3. Therefore, -4, 3 is the answer. Okay. Right. See, as far as this problem is concerned, with the available options, just by doing this much, you will get the answer. Okay. But if you have more than one option where A plus B is -1, then you have to go by this. Okay. Let's have a look at the next question, which is question number 18. The value of limit extends to 0 cos sin x minus cos x divided by x power 4 is. If we directly apply the limit, sin 0 is 0, cos 0 is 1, minus cos 0, 1 minus 1, numerator 0, denominator also 0. 0 by 0 is an indeterminate form. Okay. So though it is an indeterminate form, here I don't advise you to use L Hospital's rule, because let me just explain what happens if I use L Hospital's rule. Okay. So if I use L Hospital's rule, then derivative of this would be minus sin x into cos x plus sin x divided by 4x cubed. Now, if I apply the limit, still it is 0 by 0 only. Again, you have to use L Hospital rule. Now, it is not that easy differentiating it. Minus sin x into derivative of cos x, which is minus sin x, plus cos x into derivative of minus sin x is minus cos sin x into cos x plus cos x divided by 12x square. Now, if I apply the limit, this will be 0. Here we are going to get sin 0, 0, cos 0 is 1, minus 1, 1, minus 1. This will be plus 1. Still 0 by 0. Now, differentiating this is not that easy. It is very complicated. Okay. So, you will not have that much time, neither that much time nor that much space there. So, using L Hospital's rule for this problem is not a good idea. You may have to use it 4 times, which will take at least 10 to 15 minutes. But you will have only roughly about 1 minute per problem. Okay. So then what else can we do? You can use cos C minus cos D. What is that? Okay, don't ask me. Cos C minus cos D, you have learned this. This is equal to minus 2 sin C plus D by 2 sin C minus D by 2. Minus 2 sin C plus D by 2 into sin C minus D. Cos C minus cos D. Minus 2 sin C plus D by 2. That means sin x plus x by 2. Sin C plus D by 2. Into sin C minus D by 2. Divided by x power 4. I have not used L Hospital's rule. I just used a formula from trigonometry to simplify this. Now, limit extends to 0. Minus 2 sin of sin x plus x by 2 in divided by sin x plus x by 2 into sin x plus x by 2 into sin of sin x minus x by 2 divided by sin x minus x by 2 into sin x minus x by 2 into 1 by x power 4. Okay, just see whether you can understand what I have written. Here we had sin of sin x plus x by 2. Okay, so something like sin theta. What did I do? I had to divide by theta, right? Here we have sin of sin x plus x by 2. So I have divided by sin x plus x by 2. Then to compensate it, I have multiplied by sin x plus x by 2. Similarly here, sine of sin x minus x by 2 we have. I have divided by sin x minus x by 2. Imagine this as theta. Sin theta is there in the denominator, you want theta. So I divided by sin x minus x by 2 and therefore multiply by. Now observe this much. This will be equal to 1. Similarly, this will also be equal to 1. How? When x approaches 0, sin x will approach 0. X will also approach 0. When x approaches 0, sin x plus x by 2 also approaches 0. So this is as good as limit theta tends to 0, sin theta by theta. So this is equal to 1, this is equal to 1. Then what we are left with? Limit x tends to 0. Here sin x plus x by 2, sin x minus x by 2. Here one of those two I will cancel. Okay, minus is remaining. Minus of sin x plus x into sin x minus x. I'll write that as sin square x minus x square. Divided by another 2 is remaining into x power 4. Take this minus inside. So limit x tends to 0, x square minus sin square x divided by 2x power 4. X square minus sin square x by 2x power 4. Now I will go for L Hospital Rule. Now observe 0 by 0. You might say now using L Hospital Rule is much simpler when compared to earlier. If you use L Hospital Rule now, we are going to get limit x tends to 0, derivative of x square is 2x. Derivative of sin square x is 2 sin x cos x. Divided by 8x cube. That's equal to limit x tends to 0. I'll write this as 2x minus sin 2x divided by 8x cube. If we apply the limit, still it is 0 by 0 only. Use L Hospital Rule again. Derivative of 2x is 2. Minus the derivative of sin 2x is cos 2x into 2. Divided by 24x square. Derivative of 8x cube is 24x square. I'll take 2 as common and cancel it. So you have limit x tends to 0, 1 minus cos 2x divided by 12x square. I have cancelled 2. That's equal to limit x tends to 0. 1 minus cos theta is 2 sin square theta by 2. So this will give you 2 sin square x divided by 12x square. As x approaches 0, sin square x by x square is 1. So that's equal to 2 by 12. That is equal to 1 by 6. 2 by 12 equal to 1 by 6. That's the answer. Second option. Maybe I have to explain again. Should I? No. Okay, fine. Let's go forward. Let's have a look at the next question, which is question number 19. Limit x tends to 0, 1 minus cos cube x divided by x into sin 2x. Okay. Limit x tends to 0, 1 minus cos cube x divided by x into sin 2x. Sin 2x is there, I will divide by 2x, multiply by 2x. As x approaches 0, sin 2x by 2x becomes 1, which I need not write from the next step onwards. Because you can imagine everything else as one function and this as one other function. So limit x tends to a f of x into g of x can be written as limit x tends to a f of x into limit x tends to a g of x, right? So as x tends to 0, sin 2x by 2x becomes 1. So remaining things are limit x tends to 0, 1 minus cos cube x divided by 2x square, x into 2x. Now if we apply the limit, we are going to get 0 by 0. Therefore, I will use L Hospital Rule. L Hospital Rule derivative of this is minus 3 cos square x into the derivative of cos x, which is minus sin x, whole divided by derivative of 2x square is 4x. As x tends to 0, again sin x by x becomes 1. So apply the limit here, cos 0, that is 1, minus 3 into minus 1. 3 divided by 4. 3 by 4 is the correct answer. 3 by 4, which is the third option. Directly also I could have used L Hospital's rule, but differentiating x sine to x is slightly difficult when compared to differentiating 2x square. So I have gone with this one. Then have a look at question number 22. If f of x is equal to 1 minus cos kx by x sin x if x not equal to 0, and 1 by 2 if x is equal to 0, is continuous at x equal to 0, then the value of k is. Okay, this question was asked in last year's CET. It is continuous at x equal to 0. Since it is continuous at x equal to 0, means limit extends to 0, f of x must be equal to f of 0. Limit extends to 0, f of x. 1 minus cos kx divided by x sin x is equal to f of 0, which is 1 by 2. If we directly apply the limit, we will get 0 by 0. Here also, I'll write like this. 1 minus cos kx divided by x square into sin x by x. I have divided by x, therefore multiplied by x. Okay. So this sin x by x as x approaches 0 becomes 1. And the limit extends to 0, 1 minus cos kx divided by x square. Okay. So now if we apply the limit, still it is 0 by 0. 0 by 0 means we can use L Hospital's rule. Differentiate this. Differentiate this. What do we get? Sin kx into k divided by 2x is equal to 1 by 2. 2 gets cancelled. So limit extends to 0. Sin kx by x will be equal to k. You have limit extends to 0. K into sin kx by k by x equal to 1. 1 by 2 we have cancelled. Equal to 1. Now this value will be equal to k because you have to multiply and divide by k, right? So k into k square equal to 1. This will imply that k is equal to plus or minus 1. K equal to plus or minus 1, which means fourth option is the right answer. Okay, students, as I see, as always, the number of participants is coming down, because of my teaching. So with that, I will stop today's class. Further, if you have any doubts, you please ask me, or any questions to be explained again, you can ask me. 16 first. First, let us look at question 16. Okay, 16th question means, see, they have given that if a limit extends to 0, cos 4x plus a cos 2x plus b by x power 4 is finite. Okay, then the values of a and b are respective. It is finite, they have given. Okay. So now if we directly apply the limit as x tends to 0, we are going to get to cos 0, which is 1, plus a into cos 0, that is 1. A cos 0 is 1, a into 1 is a, plus b. 1 plus a plus b divided by 0. Okay. So now if you directly apply the limit, you are going to get 1 plus a plus b divided by 0. Now suppose, let us imagine numerator is positive. If the numerator is positive and the denominator is 0, then it will tend to plus infinity. If the numerator is negative and denominator is 0, then it will tend to minus infinity. So but they have, if that means the value of this limit is infinite, either plus infinite or minus infinite, depending on whether numerator is positive or negative. But now they have given that the limit is finite. It is finite means this cannot be positive, cannot be negative, which means it must be 0. It must be 0. 1 plus a plus b must be equal to 0. Therefore a plus b is equal to minus 1. A plus b is equal to minus 1. Look at the options. There is only one option which says a plus b is minus 1, and that is the third option. So that's it. That's the answer. Third option. Okay. Go to first question. First question was fairly simple. Maybe you have joined later. Okay, I'll explain. Limit extends to 1 summation k from 1 to 200 x power k minus 200 divided by x minus 1 is equal. So sigma k from 1 to 200 x power k, its meaning is go on putting values for k starting from 1 till 200. So x to the power 1 plus x square plus x cube plus x power 4 and so on till x power 200 minus 200 divided by x minus 1. Now if we apply the limit, you are going to get a limit as x tends to 1. Now we are going to get 1 plus 1 square plus 1 cube plus 1 power 4 plus 1 power 5 and so on till 1 power 200. Each of those terms is 1. His value is 1. 1 plus 1 plus 1 is 200 times. That will give you 200. 200 minus 200, 0. Numerator 0. Denominator 1 minus 1, that is also 0. 0 by 0 is an indeterminate form. So I will use L Hospital's rule. Derivative of x is 1. Derivative of x square is 2x. Derivative of x cube is 3x square and so on. Derivative of x to the power 200 is 200 into x to the power 199 divided by x minus 1, whose derivative is 1. Okay. So now you apply the limit as x tends to 1. So 1 plus 2 plus 3 etc. up to 200. 1 plus 2 plus 3 up to 200. That's some. It looks like 1 plus 2 plus 3 up to n. That is equal to n into n plus 1 by 2. So here 200 into 201 by 2. That simplification will give you 20,100. Okay. Next, 9th question. 9th. Okay. So limit extends to 0 e power step of mod sin x divided by step of x plus 1. So mod x is defined as x if x is positive and minus x if x negative. Similarly, mod sin x is defined as sin x if sin x is positive and minus sin x if sin x is negative. Okay. So now x is approaching 0 from left side. When x approaches 0 from left side, what happens to sin x? Or if you want, I'll give you the graph of mod sin x. I'll explain briefly how to draw the graph of mod sin x. Not this way. This is not our x-axis. It should be better. Oh, sorry. I have made a mistake here. Okay, this is the graph of sin x, which everybody knows. So here, this is pi by 2. Oh, sorry. Okay, this is pi. This is 3 pi by 2. This is 2 pi and so on. This is the graph of sin x. Now to draw the graph of mod sin x, what you need to do is take the image of the curve which lies below x-axis and write it above x-axis. Okay. So look at this portion from pi to pi, it lies below x-axis. You remove that and write it above x-axis. Its image should come up. Similarly here, its image should be written here. Similarly here. This is the graph of mod sin x. Okay. So now mod sin x, when x approaches 0, whether x approaches 0 from left side or from right side, sin x, mod sin x is approaching 0 only. Okay. So approaching 0 only. Therefore, what happens here? For left hand limit as well as right hand limit, step of sin x will become 0. So here e power 0, here also e power 0. Now let's just concentrate on the denominator. Step of x plus 1. X approaches 0 from left side, means x may take the value minus 0.1, minus 0.01, minus 0.001, etc. At all those points, what happens? If I take x as minus 0.1, then you're talking about 1 minus 0.1, that means 0.9. So step of 0.9, that will be equal to 0. Instead of minus 0.1, if I take minus 0.01, then 1 minus 0.01 will give you 0.99. Step of 0.99 is also 0. Okay. So numerator is 1, denominator is 0, hence it tends to infinity. Now for right hand limit again numerator will be e power 0 only, 1 only. Look at the denominator. Right hand limit, x approaches 0 from right side, means x is very close to 0 but greater than 0. So x may take the value 0.1, 0.05, 0.005, etc. So at that point, what happens? When I take x as 0.1, 1 plus 0.1 you get. Step of 1 plus 0.1. That means step of 1.1. Step of 1.1 is 1. 1 by 1 is equal to 1. So right hand limit is 1. Okay. Then therefore limit does not exist. Left hand limit is infinity, right hand limit is 1. They are not equal. So limit does not exist. Please upload physics class. Okay, physics class I will upload. Next, one more doubt from Sumit. Sir, if 1 plus a plus b is 0, then that is 0 by 0 indeterminate form. Then how it is finite? Okay. See, if I write 1 plus a plus b by 0, this is certainly not finite. Okay. See, if it is positive, then clearly infinity. If it is negative, it tends to minus infinity. So in those two cases, certainly it is infinite. But in case of, if it is 0, in case of 0 by 0, there is a possibility that it may be positive, may be finite. Still, see, when we get a 0 by 0, don't think that it is finite. It's a very good question. 0 by 0 is not finite. 0 by 0 is an indeterminate form. Okay. So if it is not 0 by 0, if it is like 1 plus a plus b by 0, either it is plus infinity or minus infinity, then we are never going to get finite. But if it is 0 by 0, then after simplification, after by using any other method, either by factorization or by using Hospital's rule or by any other means, if we simplify that limit further, then there is a chance that it may be finite. Okay. So, but as we leave it, if it is not 0, then it is certainly not finite. If it is 0, there is a chance that it may be finite. Okay. So I think I have clarified your doubt, Sumit. Yes. Okay. Fine. Vinith has another question. Sir, if they have given minus 4 plus 5, it will not work because they have given A and B respectively, right? A and B respectively they have given. So then A will be minus 4, B is 5. Some will be equal to 1. Some should be minus 1. Right? Okay. Then next doubt is from Tejaswini. Fifth question. Fifth. Okay. The quadratic equation whose roots are L and M, where L is equal to limit theta tends to 0, 3 sin theta minus 4 sin cube theta by theta. and m is limit theta tends to 0 to tan theta by theta into 1 minus tan square theta is. Okay. So we are asked to find a quadratic equation whose roots are 2 and 3. Whose roots are L and M. Okay. So that means first we shall find out what is L. What is L? They have given L as limit theta tends to 0, 3 sin theta minus 4 sin cube theta by theta. Okay. So let us evaluate that limit first. Limit theta tends to 0, 3 sin theta minus 4 sin cube theta by theta. That's equal to limit theta tends to 0, sin 3 theta by theta. We got. That must be equal to 3. How? Here you have sin 3 theta. So in the denominator also we want 3 theta. Divide by 3 and therefore multiply by 3. As theta tends to 0, this much will become 1. 1 into 3 will give you 3. So we got L as 3. Then for M, limit theta tends to 0, 2 tan theta by theta into 1 minus tan square theta. 2 tan theta by 1 minus tan square theta can be written as tan 2 theta. You know that formula. So now limit theta tends to 0, tan 2 theta by theta will be equal to 2. Because here you have to multiply and divide by 2. So as theta tends to 0, tan 2 theta by 2 theta becomes 1. 1 into 2 will give you 2. So L is 3, M is 2. 3 and 2. We want to get a quadratic equation whose roots are 3 and 2. That's nothing but x square minus 5x plus 6 equal to square. Okay. So Vinith has another question, sir. Can we apply GP for question number 1? GP, yes, you can. Say x plus x square till here. Look at this. That is in GP. So if you use GP, sum to n terms of a GP is given by a into a is x here into r power n, x power n, r power n, n is 200 minus 1 divided by r minus 1, x minus 1, minus 200 divided by x minus 1. Okay. So now after simplification, this will give you limit extends to 1, x into x power 200 minus 1 minus 200 into x minus 1 whole divided by x minus 1 whole square. Now if you apply the limit as x tends to 1, still it is 0 by 0 only. Okay. So yeah, again you have to go for L Hospital's rule. You will have to use L Hospital's rule twice. Okay. So very complicated, hence not advisable. Can be solved, but complicated. Our job is not just to get the right answer. Our job is to get the answer quickly. Of course, correct answer quickly. Okay. So it will be somewhat complicated. Hence, I don't advise you to use GP. Okay. Another doubt from Ankita. So can we apply? Sorry, sir. Today's class. Will you send recording of today's class? Ankita. Okay, I will send. Sir, why we have to take sin x graph image? No, just to make you understand, I have drawn that. Okay, I will explain later on because only 20 participants are there now. So I'll explain on another day. Okay. Then Vikas has another doubt. 10th question. Okay, limit extends to 2 plus step x whole cube by 3 minus step of x by 3 whole cube is. Okay, x is approaching 2 from right side. When x approaches 2 from right side, x is very close to 2 but greater than 2. Okay, so let us say put x equal to 2.1. If I take x as 2.1, step of 2.1 is 2. 2 cube is 8, 8 by 3 minus 2.1 by 3. 2.1 by 3 is approximately equal to 0.67, slightly more than 0.66. So I'll take 0.67. Step of 0.67 is 0. 0 cube is 0. So the answer is 8 by 3. In question number 16, if more than one correct answer is there, more than one option is giving the same answer, then explain the method of solving. Okay. So let us imagine that, okay, so in this case, we have minus 4 plus 3. There is only one option which is giving you sum as minus 1. But if there are more than one option, then what should we do? Okay. So use L Hospital's rule. Derivative of cos 4x is because now it is 0 by 0 form. Use L Hospital's rule minus 0 minus sin 4x into 4 plus a into derivative of cos 2x is minus sin 2x into 2 plus the derivative b is 0 divided by 4x cube. Now if I apply the limit as x tends to 0, sin 0, 0, 0 by 0, 0 by 0, L'Hospital's rule again. Derivative of sin 4x is cos 4x, so you get cos 4x into 4. So minus cos 4x into 4 into 4, that will be 16. Minus a into sin 2x is there, whose derivative is cos 2x into 2. Already there is a 2 sitting there, so 2 into 2 it will become 4. Divided by the derivative of 4x cube, which is 12x square. Now if we apply the limit as x tends to 0, we are going to get cos 0, which is 1. So minus 1 into 16, minus 16 here. And this cos 0 is 1, will give you minus 4a divided by 0. Now again the same scenario. If the numerator is positive, then it will tend to plus infinity. If the numerator is negative, it will tend to minus infinity. But given that it is finite, so it has to be 0. So it has to be 0 means minus 16 minus 4a equal to 0. From there you get 4a equal to minus 16, hence a equal to minus 4. Then substitute and simplify, I'll get b equal to 3. Okay. Okay, Vikas has another doubt in question number 10 again. Okay, so your doubt is from where did I get 0, right? So x is approaching 2 from right side. When I say x is approaching to plus, means x is lying in this interval. X is very close to 2 but greater than 2. Let us say 2.1. So 2.1 divided by 3. What do you get? 0.67, right? 0.67. What is step of 0.67? That is equal to 0 only. Instead of 2.1, if I write 2.01, then it may be 0.6667. Then also 0. Is it clear, Vikas, now? Step of x when x is between 0 and 1. Then when x is between 0 and 1, step x is equal to 0. Okay. Okay, that's it. I think I have answered all your queries. Furthermore, if you do have any doubts, please ask in our WhatsApp groups. Thank you.